Version 2 PyWebAPI web IDs have a publicly exposed specification which allows us to build them from scratch. Before getting started with this, I would first recommend confirming that your PyWebAPI instance is at least version 2017 R2, also known as version 1.10. You can check this on the system endpoint of the PyWebAPI. Once we've confirmed our PyWebAPI version is sufficiently new, we can start looking to create web IDs. First, let's start looking at web ID types. When querying for points, elements, or attributes, one of the URL parameters we have available to us is the web ID type. This allows us to specify what kind of web ID is being returned to us. We have a couple of different options available to us, but we're going to focus on full, path only, and ID only. I'd like to take a moment to note that local ID only and default ID only web IDs are not compatible with load balancers, so please keep that in mind when developing your organization's architecture and your custom application. Full web IDs contain the GUID as well as the path encoded in them, and are resistant to being moved and renamed and deleted. ID-only web IDs are shorter and will always refer to the same object, whether that be a PyPoint, AF database, and so forth, even if that object is moved or renamed. However, ID-only web IDs will no longer be valid if the item is deleted and recreated. Path-only web IDs encode the path into the web ID and will always refer to the same location in the AF hierarchy and is not resilient to renaming or moving, but will refer to the same object if it is deleted and recreated with the exact same name in the exact same location. So, with some of the background information, you're probably wondering why you would want to create web IDs from scratch. Well, if you know you're going to be working in a high latency environment, say, your application is on an offshore oil rig or off in Siberia, and your PyWebAPI instance and data archive is 500 miles away, this can severely impact your application's performance, because oftentimes it's necessary to retrieve the web ID of an object to make a subsequent call. So, if you can generate the web ID, you can go immediately to call the information you want. Another benefit is that by using path only or ID only in the URL parameter, you can reduce the amount of information sent over the wire. The web IDs are inherently shorter than they would be with full web IDs, which is the default. So if you're making large batch calls and requesting hundreds or thousands of objects, the savings in each one of the web IDs being smaller could be huge in the long run. So, how is a web ID formed? It has 2 to 3 main portions: a specifier, the encoding of the GUID, and the encoding of the path, depending on which web ID type you're specifying. The specifier is 4 characters, 5 in some cases, which assists the PyWebAPI in knowing how to translate the rest of the web ID. The first character specifies what type of web ID the following is going to be. So we have F for full. We know to look for both GUIDs and the path, I for ID only, and P for path only. The second character is going to specify the web ID version. As I mentioned in our previous video, a 1 is for version 2.0. The next 2 to 3 characters are going to be the marker. The marker lets us know what type of object the web ID is generated for. EM is for element, DP for Data Archive PyPoint, FM for AF event frame. Some objects have 3 characters for the markers. You can take a look for the markers of each object in the URL listed in the PowerPoint. Insofar as the structure of the full web ID is concerned, the server ID comes followed by the AF object ID. Both of these are GUIDs that have been base64 encoded. Since GUIDs are a fixed length, both of these are affixed 22-character encoded length. Following this, we have the base64 encoding path. In the case of ID-only WebID types, it's the specifier followed by the encoded system GUID, and then the encoded AF object GUID. Similarly, for path, the specifier, and then the encoded path. So now we're on to the meat of WebIDs. I've got a little bit of the startup code for an HTTP client in C#, and we'll be adding to it. We're going to start with encoding and decoding path-only WebIDs, since it's more common and a little easier to wrap our head around than ID-only WebIDs. In this case, we're going to be querying for a tag on the data archive. So, we know we need to set up the specifier. We'll be using P since we're using a path-only. The version is going to be 1 since it's WebID version 2.0. The marker for PyPoints is DP. And the path to the PyPoint is the name of my data archive, 1/ to escape the second slash, and then the name of my tag. Paths are the base64 encoding of the uppercase string path to the object. So if we take our path here, Venus / my tag, we can use some of the built-in C# libraries to make the byte array. Since URLs have special character considerations, we'll need to remove any special characters. Specifically, we'll be replacing pluses with dashes and // with underscores. So what we have so far are all of the pieces for the WebID of a path-only WebID. So let's try to build up the WebID and make a request to confirm this functions properly. I'll also be adding this write to console line here so that we can compare the path-only WebID to the full WebID. I have a deserializer here so that we can see the response returned to us once the request is complete. We see that our path-only WebID request did in fact return to us the correct tag. You'll also notice that in the response, the WebID listed here is the full WebID version. When you compare the two WebIDs, you'll notice that the encoded path can be seen in both. Now, if we wanted this to return the path-only WebID in addition to us requesting it by the path-only WebID, we could change the URL and add that parameter in. Let's do that. Now, when we see the response returned to us, we see that the path-only WebID is the same one as being listed in the response. Additionally, you'll notice that each of the links are much shorter as they only contain the path-only WebID as well. This is saving on the overall size of the response message. If we wanted to decode a WebID, we could just apply the reverse operations we applied to get here. Strip out the marker inversion, replace the pluses and forward slashes, we could convert the string back to a byte array, and then from UTF-8 encoding into ASCII. So what about ID-only web IDs? These are a little trickier. Let's show how decoding one would work so we understand it a little more fundamentally. We take the first 22 characters following the specifier, since we know this is going to be our server ID. Now, base64 encoding needs the string length to be divisible by 4, so we can add padding to the string by using the equals character at the end of the string to get this to 24 characters. From here, we want to go from base64 encoded to a binary array of UTF-8 characters. These binary characters can then be converted into their corresponding hex representation. This hex representation can then be read using Microsoft's GUID format to make our GUID. Since Microsoft's decoding pattern for GUIDs, we can use built-in C# libraries to form them. The process for the object ID is the same. Again, using IDs is a little trickier, in part because you either need to have the server or object IDs beforehand, or have it cached, in which case you've already made some calls to the PyWeb API to get information to begin with. So we've taken a pretty in-depth look at how to create web IDs from scratch. Caching and creating web IDs is one way to significantly improve the performance of applications in certain situations. Since encoding and decoding web IDs for a given web ID type is effectively the same process for all AF objects, I would recommend writing a helper file with functions to do this on your behalf. As I mentioned, web IDs will allow you to make the call directly for the piece of information you need, rather than requiring you to retrieve the web ID before retrieving data. Using smaller web ID types can also allow you to reduce the size of the call, and, depending on which type you use, can be resilient to certain changes. We hope you take advantage of some of the web ID creation in your applications.